Hello, my name is ChristineKoehmstedt, and I am presenting problem 6 for our regression network module, module 6. This is for class HAP 823, taught by Dr. Farouk Alemi for George Mason University, and it is spring 2025. So let's jump in. Here's the problem that we need to solve. So 1, draw a network that explains variation in Y from its direct and indirect causes. 2, draw the network based on the following 5 equations. So here we can see 5 equations for lasso equations. We need to keep in mind that statistically significant variables are indicated by a circle, and Y occurs after all other variables. R squared less than 5% and coefficients less than or equal to 0.05 can be ignored. Information is not available on whether X's occur after one another. Make sure that we remove cycles. So when interaction of 2 variables is significant, we will treat both variables as significant. Here we're going to map out our first regression. So we need to lasso regress variables on the preceding variables. However, this is our first regression. This table shows the column for Y. So it's binary, 1 and 0. So it shows our constant mapped out, negative 0.05. We see Y mapped to x1, 0.2 as the coefficient for x1. Then we see negative 0.6 mapped to x4, which is the coefficient for x4. And then later we see the interaction term x2 and x3 mapped to its coefficient of 0.3, which is the only statistically significant variable here, and then r squared of 0.8. So moving on. Here we see the table again, and we just note that the only direct causes of Y in this regression are x2 and x3. Moving on to our next equation, we map the lasso regression results for x1, which is y-intercept of negative 0.1 plus 0.2, the coefficient for x2, 0.3, the coefficient for x3, which is significant, plus 0.2, the coefficient for x4, also significant, and a r squared of 60%. So because the r squared 60% is greater than the 5%, we will map this out. So x1, we have negative 1 as our constant. We skip x1. So x1 and x2, we put 0.2. x1 and x3 is 0.3. And statistically significant x4, 0.2, again statistically significant, and our pseudo r squared is 0.6. So here we need to note that the direct causes are x3 and x4 for x1. Moving forward, our regression equation number 3 for x2, we have a y-intercept of 0.1, a coefficient of 0.05, which we will ignore, and it's listed as statistically significant, but because that is so small, we will ignore it. Plus 0.25, coefficient for x4, noted as statistically significant, and r squared of 60%. So because r squared, again, is greater than 5%, we will map this out and identify the direct causes. So again, we're going to ignore 0.05 and list out 0.25 under x2 and map it with x4. And again, the pseudo r squared is 0.6. So the only direct cause that we need to keep in mind here is x4. Okay, our next regression equation is for x3. And because the r squared is less than 5%, we are going to ignore this altogether. So I have grayed this out, and we'll move on. All right, so our last regression, we have the results for lasso regression on variable x4. the regression or the R squared is 24%, so greater than 5%, we will map this out and identify the direct causes. And so we do not have a y-intercept for this question, regression equation. Point 1, we have 1.2 as our coefficient for x1 noted as statistically significant, minus 5, the coefficient for x2, also statistically significant, and 13, the coefficient for x3, again, statistically significant. And we have those mapped out, x4 mapped to x1, x4 to x2, which is -5, x4 to x3, which is 13, again, statistically significant, and our pseudo R squared is 0.24. I've highlighted in teal blue that the direct causes of x4 are x1 and x3, so we need to note those moving forward. The next, our very important next step is to remove cycles. So we only have one significant cycle that needs to be removed for our next steps. So x4 to x1 and x1 to x4, we have two significant relationships here in direct causes. And the weakest one is 0.2 for x1 maps to x4 compared to x4 mapped to x1. So we will only keep x4 to x1, which is 1.2. Now we have the statistically significant variables from our lasso regressions. The next step will be to draw the network based on the results. So based on the network, the regression network, here are the relationships we will map out. So we need to map out x2 and x3 to y. We need to map out x3 to x1 and x4 to 2 and x1 and x3 to x4. Let's go step by step. So 2y from x2 and x3. We draw arcs from x2 to y and x3 to y. Now we need to draw an arc from x1 from x3 to x1, which we see here at the bottom. Next, we will map an arc from x4 to x2, which we see here. Lastly, we need to draw two arcs, one from x1 to x4 and one from x3 to x2. So this is our final network, and that's it. There are no arcs. These are all clinically significant relationships, and yeah, all done.